Hi guys, Miss Cochran here, and we're looking at your study guide for Trig Part 1. I'd like to start with problem number 1. I am going to be skipping around, but when we look at problem number 1, you can't fill these in until you have all three sides. We already know that this is opposite the angle. We know that this is hypotenuse, and we do not know the adjacent leg. We need to find the adjacent leg. Let's call it x, okay? So we would do x squared plus 18 squared equals 21 squared. Make sure that your 21 is on the side by itself because it is the hypotenuse. 21 squared, I believe, is 441. I'm going to double check my number. Okay, so that's 441. 18 squared is 324. And we would subtract the 324 from our 441, giving us 117. Now, you have to take the square root to get x, and our answer is the square root of 117. But that reduces, it actually, if you come over here to the side, 3 goes into it 39 times, I believe. Let me double check. And then 3 goes into 39 13 times. So your 3's can come out and your 13 stays. This is the answer for that adjacent leg. Okay. Now looking at filling in your ratios, and it does say simplest form. I'll write them and then we can reduce. But your sine is your opposite over hypotenuse. So it's going to be 18 over 21. Your cosine is your adjacent, which is 3 radical 13 over hypotenuse, 21. And your tangent is opposite over adjacent. Now, when you're looking at this, 8 and 21 can reduce down. 3 goes into both of those, so this will divide out and be 6 over 7. And then cosecant is 7 over 6, just the reciprocal. Your 3 can go into 21, reducing this down a little to a radical 13 over 7. If we flip it, we have 7 over radical 13, but we can't leave, that's for the secant, but you can't leave a radical on the denominator. So if I fancy 1 the problem, we get a 7 radical 13 over 13 as its answer. For a cotangent, I could reduce this a little bit. 3 goes into 18 6 times, so that really is 6 over a radical 13. And over here, it's radical 13 over 6. But you can't leave a radical on the denominator, and I'm kind of running out of space. So when you fancy 1, it's going to make it 6 radical 13 over 13. And that would be the reduced answer for all of number 1. Sorry, I didn't have a lot of room to write. Now, a lot of students think that 3 and 4 are much different, and they're like, oh no, what do I do to these? The exact same thing. They just didn't give you a diagram. So you know that tangent is opposite over adjacent, correct? Draw yourself a picture. Then if you put your angle at this top corner, okay, there's my theta. Opposite would be the 2 would sit here, and adjacent, the 7 would be over here. So you have your opposite and you have your adjacent. You need to find the hypotenuse. So, and once you find the hypotenuse, doing Pythagorean's theorem, you can then fill in this. Now I'm going to move on. I just wanted to get you started. And on 3, secant. Remember that secant is like cosine. And cosine is your adjacent over your hypotenuse. So they gave you hypotenuse and they gave you adjacent. Draw a picture, okay? And then do Pythagorean's theorem to find that missing piece. And then you can fill these in. So I'm going to leave you to work on 2 and 3 later on. But I want to go to number 5 and 7. Okay, these are all right triangles if you look at this whole section. So all of this section, they have the little boxes in there. So this whole section can be done with our SOHCAHTOA, or our C1 hippie, catch another hippie, tripping over apples. Okay, so you guys can do this whole section with this your ratios, your trig ratios. Now I'm going to do 5 and 7. 5 has a side that is missing. It happens to be the hypotenuse, and the 18 angle across from it is the opposite. So this particular problem is a sine problem because it has O and H. It is sine of the 18 degrees with the O number over the H number. Now these have been hard for a lot of students to work. So be very, very careful when you're solving this one when x is in the denominator. You could put a 1 under this and cross multiply. That's kind of a favorite way. Or you can multiply both sides by x. Which do you prefer? Okay. If I put a 1 under it and cross multiply, I'll get x times sine 18. And on the other side, I get 21 times 1 is 21. I'll then divide by sine 18. And when I divide by sine 18, I end up with, let me put this in our calculator, 21 divided by sine 18. And our answer, 67.957. So we could round that off. It did, I think, say, well, to the nearest tenth. But even the nearest tenth, the 9 is going to go up, forcing it to go to a 68.0. So look at number 7 with me. And when you look at number 7, you are given the opposite of the angle, and you're given the hypotenuse. This one is also a sine problem. So it's sine of the angle theta that we don't know, with the opposite over the adjacent, the opposite over the hypotenuse. So you've got 34 over 35. And to get rid of the word sine and to solve for theta, you simply do the inverse sine of 34 divided by 35. I'm going to type that one in. So inverse sine 34 divided by 35. And our answer, 76.3, would be the nearest tenth. So our theta is 76.3 degrees. And that is page 1. Just a quick review so that you can work on the others and study. If you will, go to page 2 of your study guide and problem number 8. This whole section talks about radians to degrees and degrees to radians. So I'm just going to pick a handful of these out and work with you. I'll start with maybe number 9. And it has a negative 54 degrees. If I want to make it a radian, I'm going to multiply by pi over 180. It's really like just multiplying across the top and then reducing your fraction. Now I showed a shortcut. Those of you who don't really like reducing fractions very much, you could just type your negative 54 divided by 180. Ignore the pi and just carry it over. Press enter, it gives you a decimal, and then you can hit math and change it to a fraction. So it is negative 3 over 10. Pi. And that is our answer for number 9. Now, for problem 11, you have a pi, and we can do 2 different methods. I'll do this one, the easier method to me, is to know that pi is 180 degrees. And if you know that, then you can simply replace pi with 180 and then type this in your calculator. So 9 times 180 divided by 5 gives us 324 degrees. So that is our answer for number 11. If you'll look at maybe one more of this type, number 13. I'm going to show a different method. I could just plug in though and see where pi is. I could just replace it with 180 because I know that's the degree number for pi. But you can also just multiply it by 180 divided by pi. This is just another method. And when you do that, you end up with 4 times pi times 180 all over 45 times pi. Now, it was negative, so the negative will just stay. Now, you could cancel your pi over pi. And then you're really just saying 4 times 180, which is 720 divided by 45. And you end up with 16 degrees. It is, though, negative. So if it starts out negative, it stays negative. It's just a negative. Remember, negative is just the direction of the way it swings. If we were graphing this, it would swing downward. Okay, 16. So now let's look at number 14 and 15. Remember, to find coterminal, this is where we just add 360 or we subtract 360. They wanted one positive and one negative, and they want the reference angle. Now, the reference angle is either how far is it from 180 or how far is it from 360. So you may have to think about that one. I hate to do both of these and not leave you one to practice, but I think I'll go ahead and do them both just because. If we're doing coterminal 305, you just add 360. There's one, and it's positive. So this is one answer that is possible. But these are unlimited answers, okay? I could have taken the 305 and subtracted 360. And that gives a negative answer. And we can keep on, if we need more of them, keep adding 360 or keep subtracting 360, and you'll get your answer. Now, reference angle, because this is a 305, and if you were kind of thinking about where 305 is, it would start over here and kind of swing this way and be somewhere in here. How far is it from being 360? 55 more, right? So the reference angle to this one is 55 degrees. Now, but if you're looking at one that has radians, okay, well, coterminal, remember we just said we add 360 or subtract 360. Well, in radians, 360 degrees is 2 pi radians. So you're really going to add 2 pi. Now, we need a 10 to be on the denominator. So that really makes it 20 pi over 10, because that is 2 pi if you reduce 20 and 10. Now, if we add 20 pi over 10, you're going to get a 27 pi over 10. This is one of your answers. And if we subtract, so I'm going to take that again, our 7 pi over 10, and I'm going to subtract 2 pi, which we converted to 20 pi over 10 to have a denominator that matched. When you subtract, you end up with a negative 13 pi over 10. And that is our answer. Now, it's a little bit trickier finding the reference angle when it's a radian, but let me help, okay? I may even draw this on some notebook paper just a little bit. Now, so if you think about pi is 180 and pi is over here, okay? Couldn't that be written, since ours has a denominator of 10, couldn't pi be written as 10 over 10? Isn't that still 1 pi? Okay, so the reason I'm telling you guys this is because some people need to know where is this, which quadrant is 7 pi over 10. Well, if this location is pi, that's 10 pi over 10. So 7 pi over 10 is somewhere in here. And what is their difference? Okay, well, think about it like this. If I had 150 here, let's just pretend for a minute. If I had the number 150 in degrees and that was 180, wouldn't it be a difference of 30? Wouldn't you just say 180 minus 150 is 30 and that's the reference angle? So in this one, you would really just take your 10 pi over 10 and subtract the angle, which was 7 pi over 10. Now, this is one way to do it. There are others, but this would give you 3 pi over 10, which is, in fact, the reference angle. Now, some students are like, could we just make it a degree and do it as a degree and then convert it back to a radian? You can. That is an okay method. But so if you wanted to just make that a degree by plugging in 180 and divide by 10, let's see, that would be 126. So you guys could have just said 180 minus 126 and got the angle 54 and then converted the angle 54. If you convert the angle 54, it is 3 pi over 10. Okay, now I'd like us to keep moving, and I'd like to do 17 with you. Okay, now it's similar to the problems 1, 2, and 3 we were doing. It's just a little different because you're not really using your opposite hypotenuse. I mean, you can, but you don't really have to. A lot of them we call X and R, and let me draw. If we move 9 out and 3 up, 9 would be here, 3 would be here. This would be the location, and that would be the angle. We called it X, Y, and R. And we often need to do X squared plus Y squared equals R squared and find the R. It's no longer inside the unit circle. It's not a 1 here because you went 9 out. So if you do this problem, your 90 would be there. So you have 9 squared plus 3 squared equals your radius squared. 9 times 9 is 81. 3 times 3 is 9. If you add that together, you get a 90. Take the square root of 90, and we need to break that down. If you just write it over here somewhere off to the side, you could do 9 and 10. 9 breaks into 3 and 3. 3 comes out. 10 really breaks, but not with couples. So it's going to have a 3 radical 10 as the radius. Now, or the hypotenuse, if you want to call it hypotenuse. So sine, you can do opposite, but it's the y over the r. Is what we talked about, y over r. Cosine is x over r, and tangent is y over x. And these are just the reciprocal functions. So once you know these answers, you can just flip them over. So if we're doing sine, sine is the 3 over the, or opposite over hypotenuse even. You could do it that way. It wouldn't matter. You would get 3 over a 3 radical 10. Your 3's are going to cancel, but you still have to multiply by your fancy 1. It ends up giving you a radical 10 over the number 10. If you had it flipped, you would have your 3 radical 10 over a 3, which the 3's would cancel, leaving you just a radical 10. Okay. we can continue. The x is the 9 over the r. And the tangent is the 3 over the 9. And then it reduces to 1/3. And this would be 3. Over here, you could reduce first your 3 and your 9. And 3 goes into 3 once, 3 goes into 9 3 times. So it would be 3 over radical 10. I'd go ahead and maybe flip it. But we can't leave a radical in the denominator, so I would fancy 1. Excuse me, leaving you 3 radical 10 over 10 for that answer. I tried to write it in. It's not much room to write in these little boxes, but I hope that that was helpful. And you could still talk about it as opposite and hypotenuse and adjacent leg. It still will work that way. I'd like you to look at some unit circle questions now. And it asks, and these are really easy questions, but you have to think about where are they positive, where are they negative. And it says which trig functions are negative in quad 4. So if you think about your all students take class, cosine is positive. So that means sine and tangent should be negative. And they're reciprocals. Now, I don't really think they'll ask you the reciprocals here, but their reciprocals would also be negative, okay? In 19, notice it says cosine of theta is less than 0. Less than 0, isn't that numbers that are negative? Numbers that are less than 0 are negative. So they're saying negative numbers. And then over here, it's saying cosecant is also less than 0, so it's negative. And to try to help, they're wanting to know which quadrant is this. Well, isn't cosine our x value? And isn't this like the same as sine? And sine is y. It's just the reciprocal of sine. So you're asked, where's x and where's y negative? What quadrant are they both negative? Yeah, quadrant 3. And that is your answer to those two little questions. Let's go on a little more. And now we're getting into exact values with our unit circle. Okay. I told you guys what I would really know on this is that cosine is x, sine is y, tangent is y over x. I would know where my 30, my 60, and my 45 sit. 30 is at radical 3 over 2 and then 1/2. 60 is just the flip of that. They just interchange their x and y. And 45 is radical 2 over 2, radical 2 over 2. Now, if you know this, you should be able to answer these. I'll start with one that's a little bit easy, and it's number 20. And it says sine of 45. Well, sine of 45 means the y value of a 45. Well, 45 is y value is right there, radical 2 over 2. And that is the answer they are looking for. It would be positive because everybody in quad 1 and 45 sits in quadrant 1. Everybody in quadrant 1 is positive. Now let's go to one that maybe is a little more difficult. Okay? Cotangent of 135. Well, cotangent of 135 really is like me doing tangent, which is our y over x. And 135, do we know which angle that acts like? If you think about where it sits, doesn't 135 sit right here? How far is it from 180? 45 away? So it's going to do the 45 numbers, okay? Because it's 45 away from being 180. So now we're doing cotangent, not really tangent, and all we do is flip it. So we're really going to do x over y, which means we're doing radical 2 over 2 divided by radical 2 over 2, which really is the value 1. But then we have to think about what is that x and y in this quadrant. One way to do it is all students take class, and it's in the S, where sine is positive. If sine is positive, then tangent must be negative. Another way you could say that is in this quadrant, isn't it to the left and then up to plot a point? Left is negative, but up is positive. So your x values are negative and your y's are positive. It still gives a negative answer. Let's do another. Number 23. When I'm looking at it, the first thing I'd go is, what is 4 pi over 3? I would convert 4 times 180 over 3. And that gives 240. So we're really finding a 240. Now, how far is 240 away from, 240 would be in here somewhere. How far is that away from 180? 60. So this angle really does what the 60s do. 60 is its reference angle. Okay? And if 60 is the reference angle, it's going to use these numbers for x and y. And in tangent, the y number, so it's the y over the x, and the y over the x is radical 3 over 2, and then 1/2. Now, I like to do the little outside-inside trick just so I can multiply quickly. So when I multiply the outside, I get a 2 radical 3. When I multiply the inside numbers, I get a 2. The 2's cancel, and my answer is radical 3. Now, I will check to see, is it positive or negative? And tangent in this quadrant 3 is always positive. Remember the all students take class? Tangent's positive in that quadrant, so it's got to be a positive. I could do another. I'd like to save some for you guys to try. Is there a preference on any of these? Which ones I do? I know there are a lot of them in radians. One class asked earlier about number 28, so I could do it. It's just a little different. It's cotangent of pi. When you think about pi, isn't pi 180? And where does 180 sit? Doesn't that sit at negative 1, 0 on the unit circle? Isn't it just out one place to the left? So negative 1, 0. And cotangent, remember tangent is your y over x. So cotangent would be x over y. If I take the x number, it's negative 1. If I put it over the y number, 0. This one is undefined. Okay. Now, I want to keep going and do a few more with you guys. So I'm going to look at a law of sines now. And we need, for a law of sines, we need one set of opposites. And this one has it. The 77 is opposite the 12. So we can say sine of 77 over 12 equals, and then we can do the 68 over x. So we do sine of 68 over x. If we cross multiply, we can solve this problem. Okay? So you have 12 times sine 68 on one side, and on the other you have x times sine 77. You can divide by sine 77 to move it, and we'll get x as answer. Let me plug this in my calculator now. So I have 12 times sine 68. That's all on top, so I'll enter, and then divide by sine 77. When I do that, I end up with a 11.4 for the answer. So 11.4 is our answer to number 29. Okay. To just kind of keep going, let's look at 31. 31 has no diagram, but it called it ABC. I'll draw my own ABC. A is 40. AB is 26. BC is 20. And it wants angle C. Now, I do know that I have a set of opposite. Sine of 40 is over the 20. That's a set of opposite. And then sine of angle C could go over 26. If I cross multiply, this one will go in our calculator a little different. But if I cross multiply, I can solve for letter C. And I'm just doing a little cross multiplying. I would divide by the 21st to get it away from the sine of C. Put that in your calculator. So we have 26 sine 40, and then divided by 20 gives us the decimal point 8356. But in this problem, remember that you have to find angle C, you have to do the inverse of sine and then that number, okay? You can just type it, but I already have the number in my calculator, so I'm going to do second sine and second answer to plug that in. And remember, answer is this button down here, that little negative button. And we end up with our solution for angle C. It is a 56.6. I was seeing how 7. They ask us to round to the 10th. They did also ask, is there another answer for this? Tell all possible solutions. Well, if you think about the 56.7 and the fact that that is an angle over here, 56.7, we need to know what is it over there. So just take your 180 and minus 56.7. You end up with a 123.3. Now we've got to decide, can that 123 be possible in this triangle? Well, can we have a, I have no idea what I just pressed. Okay, sorry. I don't know where that came from. Now, could we have a 40 with a 123? Yeah, we could. Could we have a 40 with a 56 number? Yeah. Both of these answers can actually work in this triangle. Okay, so it does have two different answers to number 31. It is ambiguous. And this was the clue to check, where it said give all possible solutions. They're trying to give you a hint that there might be more than one answer. Sometimes there's even no answer, remember? Guys, would you look on at problem 34, okay? I am going to skip on a little bit to a different topic here, and it's your law of cosines. If you wanted to even write the little formula, it might come in handy as you are, working and thinking about the math problem. So I do have the x, and it's opposite the 75. So those are the ones that I'll start with and end with. Remember, the angle is always on one end and the side on the other. Then the 13 and the 17 are the other two numbers. And then you do minus 2, and you do the 13 and 17 again. Now, you have to, this one's not really a difficult one because it's one that you can just plug those numbers in your calculator. So you have 13 squared plus 17 squared minus 2 times 13 times 17 times cosine 75. You can just type everything in and press enter. It gives us 343.6019. Okay. This is not the answer. It's the answer. It's x squared. So we need to take the square root now of that number. And I will use my calculator to help me. I'm going to do second, the x squared button, and then second, the answer to plug it in. And so our solution is 18.5. So that is a finding a missing side when you're in this problem. Finding an angle, you have to go through each step, so be careful there. I'll set that one up, but I know my time is kind of getting close. So in this one, if we are finding the angle, we're going to have to start with the 22 squared. And then the 9 and the 16 would come next. Minus 2 times the 9 times the 16. And then cosine of the angle. Okay, so this is the correct way to write this one on 35. And now I can start chipping away at some of the math. You have to be very careful on this one to use your algebra steps correctly. When we multiply these three numbers together, you get a 288 cosine x. You can combine those, the 81, combine those like terms with the 256, and that gives you 337. I'm just going to bring down the remaining parts of my problem. Remember, you're solving it like algebra. This piece needs to go, and then we can divide. So I would subtract 337. If I do 484, subtract 337, I end up with a 147. Kind of running out of room in my little box, but I would divide by negative 288. And I'll bring it back over here. So divide by negative 288, and I get a negative 0.510416, and that is my cosine of x. So now I need to do cosine inverse of that negative 0.51 number. So I'm going to use my calculator to do that. Second cosine, second answer. And then it gives me 120.7 as the angle for that problem. Okay? And that is our problem number 35. Now, when you get into number 37, you may have to use law of sines and cosines to solve the whole triangle. Okay? And let me see. Let's do an area problem very quickly. On 39, remember the area of the triangle does 1/2. If you have AB, then it is sine of the angle C. It's the angle that is sandwiched in between those two sides. So if you're looking at this problem, I would use the sine of 103. I would multiply it by the 11 and the 24, because the 11 and the 24 make the angle 103. But don't forget to half it. That is very important. It's a part of the equation. So, and it's okay to just type, I like to type the half as just 0.5 times 24 times 11 times sine of 103. If you hit enter, you've got your answer. So it is that simple. And I rounded to the 10th. Now remember, it is area, so it is millimeters squared. And that is our answer for that problem, number 39. Okay. I would love to do a couple of the word problems with you guys. I do feel like number 43 is more of a bonus kind of problem. So you might want to circle 43 as more of a bonus kind of question. But if you'd like to look at 42, let's start there. And this may have to be my last one. It says from the top of a building, the angle of depression to a car parked on the street is 48 degrees. If the building is 75 feet tall, how far is the car parked from the base of the building? So I would try to draw a little building and maybe a car. That is going to be my car. Okay, I know you love my art. And from the top of the building looking down, it said the angle of depression is 48 degrees. It says the building is 75 feet tall. So this number from ground up is 75 feet tall. It wants to know how far is the car parked from the base of the building. So we're really looking for this number, okay, across the bottom there. All right, so if you will, here's my 9D. Remember that alternate interior angles are congruent, and you can flip that 48 down there at that bottom. Then you have opposite, and you have adjacent. You could have also just put the 75 right here and the X up top because it is a square, or not square, but a rectangle, okay? So you could use either one of the triangles, the one I dotted over here or the one here. Regardless, you would end up doing tangent of 48 degrees is opposite over adjacent. I would put a 1 under and cross multiply it. When I go this direction, multiply, and I have X times tangent 48. When I go that direction, I have 75 times 1 is 75. I would then divide by tangent 48. And when I divide by tangent 48, my answer, and I'm going to run to my calculator now. And we have 75 divided by tangent 48. And my answer is 67.5. Now remember, this was a distance and it was feet. This was feet, 75 feet tall. So this distance, the car is 67.5 feet away from the base of the building. Okay. Guys, I hope you do well studying. Keep working on this. Tomorrow, I have your questions ready, and good luck. Test is Friday.